Hello class. Today I want to talk to you guys about some axiomatic kinds of concepts. So what am I saying here? I'm saying axiomatic. I'd rather use black right now, guys. And these axiomatic concepts basically are, and I'm going to start off with three, and those three are time, position, and mass. So the idea is that we need to agree on these things, on what it means to have time, what it means to have position, and what it means to have mass. We already have some idea, but we want to formally specify these things. And the way we formally specify, and just let me be clear on what it means to be formally specific, it means without ambiguity. It's very, very clear. There's no clouds before you when you're trying to see a thing. So time, we can refer to time, it has a conceptual representation, but we want to move out of the concept and we want to move to our ability to measure. So we measure time in seconds, okay? So we know that 60 seconds will yield a minute. And then we know that 60 minutes will yield 1 hour, and so on and so on. How many hours are in a day? 24 hours, 1 day. How many days are in a year? 365 days yields 1 year. Okay? So, but we formally, we can define the second very well. Okay? We can get out to 18 decimal places as far as how well we can define the second, the precision that's associated with that. And when I say precision, I mean, how well we can measure the thing repeatedly. So in other words, let me just give you a concept. Right now, we can lose seconds on our clock. If we just let our clock run, it's going to lose time. If you guys have ever noticed that, it'll lose time. Well, we have another way of measuring time where we will lose 1 second in 100 million years, over 100 million years, okay? And so it's even greater than that, but I use 100 million years, as opposed to a year or a day, and you have to reset your watch or reset your clock. So our ability to measure time is very, very formal, very, very specific, okay? Position, we can do the same thing here. The units of measure for position is going to be the meter. Okay. Now in America, we use the yard, we use the foot, we use the inch. Those are great. That's from the imperial system, or the British gravitational system, or the English system, or the US customary system of units. The meter is what we use in the international standard system of units. And we also use a second. So a meter is really, really good, but we want to just say, hey, we really know how to define a meter. We really, really know how to define a meter. And we actually use the wavelength of light to define a meter now. So we know we can pick an atom, okay? We know that this specific atom gives off a certain wavelength. And we know that there are a certain amount of wavelengths inside of a meter. And because we choose this atom, the wavelength of light coming off that atom never changes. Thus, our formal specificity for the meter is very, very high, okay? So that's how we do that. Now, we're able to accomplish this with time as well as position. Mass is a little bit different because things are always wearing away. So we can set up something where we have a mass, and we can use it as a standard of measure. But if we come back to that thing in 100 years, let's just say we pick a brick or a rock, and we say, all right, this is going to be the unit of mass. What will happen is over time that block or that rock will wear away. And so we are still working on figuring out the best system for calibration. So right now we're using the kilogram as the unit of measure for mass, and the meter for position, and the second for time. Thus, we have our M for meter, our K for kilogram, and our second for time. So these are our axiomatic concepts. After this, we'll go into, we'll look at this a little bit closer in terms of measurement.